This is part 5 in a series of videos in which I'm attempting to reproduce drop-in replacements for the HP9830 desktop calculator software option modules. So far in this series I've gone through creating a test jig to read the data from one of the boards. So inside each of these there is a board like this, and it contains nothing more than some ROMs with custom code in it, and each of the modules provides different functionality and options for the desktop calculator. What I have at the moment is the test jig that I made, so that is a breadboard version of this but using a more modern EEPROM. So the general idea is to make the code that resides in these available to anyone that owns a desktop calculator. Now, I can't distribute the code itself. I'm not sure what the copyright restrictions, if any, are on that, so I won't be doing that, but I'm just making the bare boards available. And the idea behind this is that if you want to get hold of one of these, even if you can find them, they're usually well over £100 each, and the idea is that the board I'm producing will firstly be quite low cost, but also will allow images for up to 32 of these to be put into it. So in other words, it should be a much more cost-effective way to get these options, and also you don't need to go through the rigmarole of trying to get hold of one of the originals. In the previous video I showed the steps I'd gone through to get to this point, did a brief test to show that the plotter was at least recognizing the code that was programmed into this EEPROM. This EEPROM contains, I think it's 12 images at the moment for different modules, and I have been going through testing each one in turn to make sure that they're working. So in this video, this will be a fairly short video, I just wanted to show some of that. And this all started because I had this plotter, didn't have the interface for it, so I posted a series of videos in which I reproduced the interface. That's what I'm now using to connect the calculator to the plotter, and then I didn't have the ROM module for the plotter. I showed that you can drive the plotter in a fairly rudimentary form directly from the calculator without the software option, but in this video I want to show the advantage of using this software option. There are many, but just give you some idea as to what you can do when you have the software option installed. You can do pretty much all of this without the software option, but it means you've got to write the code yourself, of course, and you'll see that the module does save you a lot of coding, but we'll come back to that in a few minutes. Firstly, very simple test. So the image I currently have selected in the breadboard module is the one for the plotter control, and what I'm going to do for the rest of this video, it will be a fairly short video. I just want to show some of the advantages in having these software options installed and why I've gone to the time and trouble to design a replacement board. I showed that you can control the plotter in a rudimentary form directly from the calculator, but now I've got this module plugged in, what we can do is enter a fairly simple program to do some fairly complex operations with the plotter. So I've cleared the memory. This is the only thing that's in this program. So just 2 lines of code. If we now run this, we get a question mark on the display of the calculator. What I'm going to do now is move the camera so you can see the output from the plotter a bit more clearly. Okay, well, hopefully you'll be able to see this. What I'm going to do now is just start typing characters on the keyboard. And as you can see, we can actually output text onto the plotter. Messes up the first few characters because we haven't initialized the plotter properly, but as you can see, once it gets going, it outputs text. And although you could do that directly without the module, it would be quite a complex thing to do. And this is just one of the advantages we get when we have the module fitted. But of course we gain far more than that. So what I'm going to do now is load a simple program that this is actually a test program that HP provide. It's quite a lengthy program and took a while to type in, but I've got it saved to tape, so we'll get that loaded from tape. Delete everything from memory, and then we'll load the current test program. So I'll just fast forward you through this bit. It takes about 30 seconds. Okay, so that's successfully loaded. I'm just going to move the camera across to the left so you can see the display on the calculator. And we have the program in memory. As I say, it's quite a long program, but we'll run this and it's going to allow us to output a calendar on the plotter. So run the program. Okay, so we'll enter a month and year. So that's 08-1958. We'll enter that. Before I do that, I'm going to move the camera back across so you can see the plotter output. And I'm also going to put a fresh piece of paper in. You can see I'm using A4 paper here, but you could adjust the plotter to use A3. Okay, I'm now going to press enter on the calculator. Okay, so as you can see, it's working fine. The interface is working, the plot is working, and most importantly for the purposes of this video, our interface module is working. So it's doing a test like this is fairly useful because we're repeatedly accessing the ROM module, and it's far more informative than just doing a single access. But as we can see, it's working fine. If it wasn't able to read the data from the module, we'd get all sorts of weird behavior, and it's done here a fairly complex task 100% correctly. So it is looking quite promising. I'm now going to go back, finish off the PCB layout, and in the next video in this series we'll start assembling one of the PCBs and see if that works.